Okay, so I'm going to do a video that goes with our Math 115 class from yesterday, Monday, since we had the technical difficulties. So we're going to go over part of this paper and then part of the other sheet. So both of them are uploaded on Teams near where our class would have been yesterday. So we're talking about statistics. We're going to start out by talking about what we call measures of central tendency. And these are some names and concepts that you may remember from other classes, other math classes also. Okay, so the three things we're going to talk about on this sheet are mean, median, mode. I already have them written in here, just figured that would save a little time. So you can always pause the video to write out these definitions or these procedures about how to find these. So mean is the average. To find the average of a group of numbers, we add up all the data and divide by how many there are. The median is the number that's in the middle when the numbers are ordered from least to greatest. So if there are an even number of values, well, let's start with an odd first. If there are an odd number of numbers, then the median is right in the middle. So imagine I have three numbers, so I'll use these little blocks. So let's say I have 5 numbers. So I have 5 numbers, there's from smallest to largest, the median is going to be that middle number. But if I have 6 numbers from smallest to largest, now there's not just one number in the middle, these two are in the middle. So I take these two and I find their average, or their mean. I add them up and divide by 2. And then finally, the other measure of central tendency we'll talk about is mode. My little trick is MO for mode, stands for most often. And this is the number or numbers that happen most often. And we can have one mode, more than one mode, or no mode. So I'm going to give you an example of that on the back of this paper here. So again, if you need more time to copy these down, you can just pause the video and do that. And then on the back here, I'm going to do an example for mode. So let's say, for example, I find a pen that writes. Let's say, for example, we have a data set that is 1, 1, 2, 3. Okay, so those are my 4 numbers. My mode here is going to be 1, because that's what happens the most often. What if instead my data set is 1, 1, 2, 2, 3, sorry, I know this is bouncing a little bit, then I have 2 modes here. So there are 2 things that happen more often than anything else and happen the same number of times, right? They're like kind of the winners, like they happen twice. So here, if I'm trying to find my mode, I actually have 2. My modes are 1 and 2. Now, if my data set instead is this is kind of the tricky one, okay? I can't say that every single number in my data set is a mode. So as soon as they're all tied with how many times they happen, even if they happen multiple times, then there's no mode. And we don't want to say 0 for the mode, because that would be if the number 0 were the most common. But here there's no mode because they all happen an equal number of times. I also want to kind of remind you that these measures of central tendency, they all give one little snapshot of the data, okay? So for example, let's say I'm moving to a new city and I look at the last 5 houses that were sold, okay? Obviously it's a very small sample, we'd have bigger, but let's just say I look at this. So my last 5 house prices are 80,000, 80,000, 100,000, 110,000, and 700,000, okay? If I find the mean of these values, let's say I didn't have the actual values, so all I have are these 3 measures. The mean is 214,000. Well, if I want to spend, $105,000 on a house, and I see that the mean or the average is 214, I might think that I can't afford a house there in this place, right? Even though there are quite a few houses that were sold that are right around or under my price range. But the mean is very, very affected by this high number here. So the mean pulls up. So even though most of the values are well below that, this mean, or this high value here, pulls up that mean. My median in this case is 100,000, right? That's a pretty good indicator of this data. and my mode is 80,000. So yes, that happened most often, but there are also all different values. So just kind of thinking about that. Another way to think about this, another example is I could have two different data sets. I could have 3, 4, 5, 6, 7, right? And I could have, let's see, 0, 0, 5, 12, 100, right? These both have the same median, but they are very different data sets. So just realizing again that when I am given a median, a mean, a mode, it's just one value. It's just one piece of the story about that data, right? If you say that your test average, let's say, for your science class is 80, okay, that could mean, let's say you have 3 tests. You could have gotten 80 on all of them, right? Or you could have gotten a 50 on one of them, and let's see, a 90 and 100, right? And those are just very different situations with the same average. So just remembering that any of these measures of central tendency are just kind of a snapshot. And think about the name, measures of central tendency. It's sort of what tends to happen. It gives some information about the middle value of those, but not all the information. All right, so then on the 2-page sheet, we're going to start on the second paper, the number 11 here, where it says the mean as evening out. So we know, obviously, we talked about finding the mean with adding up all the numbers and dividing by how many there are. We also want to think about how can we show this visually, hands-on, also make it a little more accessible to some younger students as well. So we can think about the mean as kind of what would happen if all of them were the same. If I say, that Johnny has 8 stickers and Bailey has 3 stickers and Timmy has 2 stickers, the mean would be, the average number of stickers is really what would the number be if they all had the same number of stickers, okay? So that's another way of thinking about mean. So we're going to kind of see that visually here, and I'm going to do it with the blocks as well. So it says, imagine that you ask 4 children how many siblings they have. Their answers are 4, 2, 1, and 5. So that's how many siblings they have. We're trying to find the mean. So we want to just see this visually. So we can do it in here also. I'm going to just do it with these blocks first, and then I'll color in on the little grid. So the first person says they have 4 siblings. The second person says they have 2 siblings. The third person says they have 1 sibling. And then the last person says they have 5 siblings. Okay, so we want to find the average number of siblings. Now obviously we're not actually changing how many siblings these people have, but the average is, what if they did have all the same, right? What would that be? So one way to think about this is that we're evening out those 4 responses, or the answers for those 4 people. Now, if I were doing this in a classroom, I may also want to have different colored blocks, and so each person's response was a different color. I'll show you why in a minute. I'll do that over here. But what I can do is I can say, well, what if I move these things around and make my towers all equal? And in this case, I can do that with no leftovers. And so my average, or my mean now, is going to be 3. Okay, we can see that that's what happens when I even those all out. So let me do it kind of on here also. And of course, it's always great to start with a concrete item, something that they can hold. So let's say the first person has 4 siblings, and the second person has 2 siblings, and the third person has 1 sibling, and the fourth person has 5. Okay, so really kind of doing what I did with the blocks here. It actually might be a great way to transition from one to the other, and also if you make the grid the right size, you can kind of fit the blocks right on there also. So now if I want to move things around, well, I know this is taller than the rest, right? So I'm going to take this one away and move it down here. And this is why I was saying it might also help if you have different colored blocks, because then as you move them, you can see, oh, well, these towers were now made by blocks that moved over. So now I have 4 for each of these, so I'm going to move one more of those purples there. and I'm going to move one of these oranges over here, right, move it from here. So now you can see kind of how we move things around, and again, we can see that the mean is 3. So what can we do to show visually what the mean is? We can make each column, which each column is a response, right, the same height. So we can think of that as evening out the responses. Now imagine that I have, instead of these numbers here, let's say that I have, the first person says 4, the next person says 2, the next person says 1, and let's say now that the next person, instead of saying 5, let's say that the next person says 6. Okay, so we're going to do the same thing. We can move things around. So I'm going to move one here, and I'll move another one there, and I'll move one of these over here. Well, now I can't make them quite equal, right? So I have 4 columns of 3, but I have this one left over. And this is why often when we have a mean, if we have one left over, that's when we get decimals, okay? So I have this one block. I need all of these 4 columns to be the same. So, let's see what I can find that I can kind of use for that. I guess I'll just write it in here. But instead, I can't make this block go in all 4 at once, but I can put a fourth of a block in each one, right? So now my mean would be 4 or 3 and a fourth, or 3.25. And that's where often we get means that have a decimal, because it's those kind of leftovers. They don't fit in exactly, right? If it's not divisible exactly, then we get those leftovers. All right. There are 2 here on the back. Same idea. So I want you to find the mean without using arithmetic. So for example here, we ask some students in your class how many pets they have. Here are their responses. So we can just use like X's maybe to show responses. So there's 1. The next person has 0, but we want to leave a spot for that person, right? It's still an answer. And then 2, 2, 1, 5, 3, 2, 1, and 1. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have to still end up with 10 columns at the end. Okay, we're just going to see if we can make them the same. So let's take this one and put it here. And let's take this one and put it here. Just trying to kind of take some of the larger ones and move them around. Let's take that X here. And this X, let's put here, and we have this X that goes here. And we've actually made them all even. So that means that my mean is 2. If I had added all of these up, I would get 20 divided by 10 spots, or 10 people. The mean is going to be 2. Okay, let's do another one here. So, and you may want to stop the video, try it on your own first. So let's see, we have 6, 1, 2, 3, 4, 5, 6, 3, 4, 2, 8, 5, and then 2 4s at the end. Okay, so again, we want to try to even these out. So again, I'm just going to start by kind of taking the largest ones and putting some of those on the smaller ones. So maybe I'll do that, maybe I'll do another one here, and I don't exactly know how it's going to work out yet, but I'm trying to sort of even those out. So now, if you look, these are all 4 high, and then I have 4 left, right? So those 4, if I want to split them up among those 8 spots, picture this kind of. I'm going to take this one, and I'm going to put half here and half here. And then I'm going to take this one and put half and half. This one, half and half, and this one, half and half. So then my mean, the way I can even that out, is 4.5 or 4.5, right? That's how many blocks each of those has. So just kind of thinking about that average. It's like if I made them all the same, what would they be? Okay, now let's flip over to the front. And we're asked here for a few of these to create a data set with a certain number of numbers, okay, with a mean of something. So in this case, we're trying to create a data set of 5 numbers with a mean of 60. So remember that this means what I'm going to do is I'm going to add up all the numbers. I divide by 5 because there are 5 numbers, and I want my answer to be 60. Okay, that's kind of what's happening here. Try to think of the simplest set you can make. Well, in my mind, the simplest set is if they are all 60. If all my values are the same, then the average of those is also going to be that value, right? So can we check this? Well, if we add these up, it's going to be 300. We divide 300 by 5, and we're going to get 60. So that works. Okay, now I would like you to create a new data set of numbers with a mean of 60. Different numbers, okay, not all 60s. So if you get stuck, think about this process here. Think about that whatever the sum is, when I divide by 5, because I have 5 numbers still, it has to be equal to 60. So let that guide you. So I would ask you to pause the video for a minute, see if you can come up with this. Now you might not know off the top of your head, you might have to kind of do trial and error a little bit, or kind of work backward. But go ahead, pause the video and take a couple minutes to see if you can come up with a data set. If you do, try doing a third one as well. If you're really, really stuck after you try, not just right now, but after you try, then you can turn it on and I'll walk through it. Okay, so we know here that whatever our 5 numbers are, they have to add up to something, where if I divide by 5, I get 60. Well, there's actually only one number that works for that. And if I think about getting this sum by itself, what I can do is I can multiply both sides by 5 to cancel that out. And that actually tells us that the sum has to be 60 times 5, which is 300. Any other number in this place of 300, if I divide by 5, I won't get exactly 60. So my sum has to be 300. So I might even just start out with some random numbers. Let's say I have these. Okay, I know I have to add up to 300, so I might add these up and see how close I am to 300, and then just add in whatever I need. Okay, I did this the other day, so I have it in front of me, so I know when I add those up, I would need 88 more to get to 300. Okay, and again, you can check it by seeing, yes, they add up to 300. 300 divided by 1, 2, 3, 4, 5 must be 60. Now, if I wanted either a different mean, or if I had a different number of values, then my sum would have to be different. Create a third one. Again, you can pause the video, do your own. And it can be, sometimes I like to look at the extremes, right? So I could even have 1, 1, 1, 1, and 296. Or I could have 0, 0, 0, 0, and 300. And to my mind, like, these two are kind of the opposite extremes, like either all the same or as far apart as you can get without going into negatives. So either of those would also have a mean of 60, because in each case the sum divided by 5 is going to be 60. So what did any set of numbers, 5 numbers with a mean of 60 have in common? The sum has to be 300. Do I need you to memorize that the sum of this specific situation is 300? No, but think about that process. So if I said, okay, let's say we want a set of 7 numbers with a mean of 100, right? Well, you would know that whatever the sum is, when I divide by 7, I have to have 100. So that would help you figure out what that sum would have to be and help you find those numbers. So you want you to see that process. Okay, we're going to do 2 more on here, and then 7, 8, 9, and 10 we're doing in class on Wednesday. We didn't do those on Monday. All right, create a data set of 5 numbers with a median of 20. So think for a minute about what a median means. Median is the middle number when they're ordered from smallest to largest. And if I have 5 numbers, then I do have one single middle number. So in this case, I like to kind of put my little slots out for my number. And I know that this has to be 20 because this is my median. Now the other numbers can be anything that I want, except, remember, this is the middle number when they're in order. So these 2 down here have to be 20 or less. And these 2 up here have to be 20 or more, because my 20 still has to end up in the middle when they're in order, right? So what I cannot do is I can't do something like this and say, okay, 20, well, I'm just going to fill in anything. So 5, 85, 88, 100, right? What's wrong with that is that if I put them in order, 20 is not my median anymore, now 85 is, right? So we don't want to do something like this. We want to make sure that we keep it so 20 is in the middle. Okay, next we want to create a data set of 6 numbers with a median of 20. So think about what that means first. I have 6 numbers. My median is 20. So that means the mean of these two equals 20, which is then going to be my median. So these two, when I add them up and divide by 2, that has to be 20. Now, it says no repeated numbers because the easiest way to do that is have both of these equal to 20. Then obviously my mean would be 20, but it says no repeated numbers. So these two, if you think about this process again, they have to add to 40. Whatever that is. It could be 1 and 39, it could be 19 and 21. Mathematically it could be 20 and 20, but we can't do that because no repeated numbers. And then these, again, have to be smaller or the same as the spot here in number 3. And these, I'm saying 3 and 4 just like this is first, second, third, fourth, right? And these have to be larger or the same as this, whatever's in spot 4. Because again, if these are smaller or these are larger, then things get shuffled around and now these two are not in the middle for the median anymore. Okay, so I can give you an example of each of these. Let's say one example for this one could be 1, 5, 20, 20, 73, right? In this case, this is still my median here. An example of this one might be, 3, 12, 18, let's see, that would be 22 to add up to 40, and then 25, and then 26, right? As long as these two add up to 40, so that when I divide by 2, I get 20. All right, so please try to, even if you were kind of not sure at first and following along, try to make your own data sets for these as well. So you see that? Tomorrow in class we'll be doing ones where we have a mean and a median, or a mean and a mode, so we kind of have to keep 2 things in mind at once. All right, so I'm sorry about the technology issues yesterday. Thank you for your patience, and I will see you guys on Wednesday.